So Rust, developed by actually Mozilla employee in 2006, and Mozilla kind of picked up the project a couple years later, I think maybe in like 2010 or 2011. But they didn't have their first stable release actually until 2015. That's when 1.0 came out. So it's really new, but it is just, as everyone probably knows, just like spread like wildfire since then. And the employee like originally developed it as like a modern kind of safe solution to C and C++, which is exactly how it's why it's become so popular. And like I said, just rapid growth. It's like they're now up to like almost 3 million developers in 2023. It tripled over 2 years. And according to the end of the year Stack Overflow kind of analysis, it has been the most admired language since 2016. Actually, the one just came out again a couple days ago, and it still is. And what they mean by most admired is that when a developer uses it, they would be willing to use it the following year. So 80% of people that use Rust would be willing to go back to it the next year. I'm very sorry for MATLAB developers, only 20%. I have a friend that works in MATLAB and can vouch for this. Yeah, so let's get into the specifics here. The biggest thing, what everyone talks about, is memory safety. That's the big benefit. And it does so without garbage collection, which is like the kind of the highlighting point here. And a quick background on garbage collection. It's an automatic memory management system or kind of feature that runs in the background. Its main purpose is to clean up memory that's no longer being used, helps avoid memory leaks, and takes the kind of burden of memory management off of the individual developer. So we have languages like Java or Python that have that in the background that are maybe not as performant, but super safe. And on the opposite end, you have things like C and C++, which are extremely unsafe, but very fast. And that's cool. And so how does Rust actually do this memory safety? So they have a unique ownership model. And ownership model kind of defines extremely clear rules for how memory is allocated, used, and freed. And so what they came up with is that each piece of data has a single owner, and the compiler is extremely very aware of who owns what. And when that single owner goes out of scope, that memory is automatically freed. And the important note is that all of these rules are applied at compile time rather than runtime. And so before you can even run your code, the Rust will throw an error and say, hey, that's not a free memory, or that's not a safe memory operation. We're not going to allow you to compile this app, or we're going to throw a warning, which is really nice. Whereas C, C++, you kind of just get slapped in the face at runtime, which is pretty nice. So Rust does this ahead of time, and if you've also ever seen any output from their warnings or errors, it's incredible, extremely clear. So yeah, so it helps avoid things like use after freeze or double freeze or data races. So extremely safe, really fun. Yeah, so next major feature is zero cost abstractions. For those who don't know, an abstraction is like a high level programming concept or like construct, like a vector or a string that is just something like very easy to use if it sits on top of kind of lower level concepts that actually run faster. And so what Rust does at compile time, it's able to take these high level concepts and compile them down as if they're written in these really low level in the really low level code, and it runs just as quickly as if you did. It's really nice. C++ has a bit of this with like vectors and strings, obviously, but you can still incur, because of the non-compile time checks, you can still incur kind of dangers there if you're not very careful. But Rust is ultra careful, so very nice. And then obviously speed. So people come to Rust really for the safety and the speed, and it's able to run as fast as a language like C or C++ because it uses the same exact like compiler techniques, LLVM compiler techniques that generate the optimized code for whatever system you're on. So it's generating extremely similar code to C and C++. And we also, on top of that, it doesn't have a garbage collector that adds overhead. Pretty nice. And then finally, one of our main benefits of Rust is that it has awesome library support. So because it's a safe and fast language, a lot of people choose to develop their libraries and their APIs in it. So for things like machine learning or image processing or linear algebra, any of that runs extremely fast, and a lot of people put out support for that. So we heavily utilize that in our app. So who's using it? basically everyone. If you Google online who uses Rust, everything shows up. It's used in many operating systems, so Android, Linux, Redux, Google Fuchsia. Meta uses it in their control system. Microsoft has all of their Windows APIs bound to Rust. System76 writes a lot of their infrastructure and kind of Linux projects. And then just to list many more, Amazon, Brave, Discord, GitHub, Figma. It's every major company is using it in some way. And if they're not currently, they probably will soon.